The distinction is there, is not between opinion and knowledge. Opinion is belief, opinion, knowledge, justification only work when you're within a rational account of our knowledges. And reason is not, I mean, our idea of perception is not that it's...
Perception is just one part of cognition.
No, but I'm just saying that the philosopher's account of justification and belief and truth are embedded within the kind of knowledge that you explicitly acquire through measurement, data, and reasoning. But that's not what our subconscious processes are doing. We don't have the capacity to justify our own perception. You can close your eyes, that's pretty much the best thing. Please, yeah.
And this question is more related to the earlier session, but also to this one. I was wondering about this school of Indian thought, which says that if you practice meditation and go into advanced levels of meditation, you can actually acquire true intuition, wherein you can actually relate to the other person and know what the other person is thinking, even feel for the other person. So how do you actually categorize this? Is this computational, or will you throw it into something which is not computational? I mean, those siddhis and all which they refer to, I mean, how can you make sense of something like that? And it's again isolated to a few people, probably. We don't even know if that exists, but even if it does exist, and so much has been written about it in the ancient texts, that you can actually acquire those siddhis, and we don't see it in our daily life. So how can one make sense of something like that?
So there are two answers to that question. One is the standard. Cognitive science doesn't deal with specialized kinds of skills, right? It deals with things that all of us do. So I open my eyes and I see the world, you open your eyes and you see the world. So it's, in that sense, it's easier to theorize that as a biological phenomenon, right? It doesn't distinguish between me and you. But in every culture, there are different people with different cities. So for example, since we are sitting in the Indian Institute of Science, there are people who can close their eyes and write equations and it predicts how matter works at the other end of the universe. Okay, that's as much of a siddhi in some sense than as being able to meditate and see what you're thinking. Okay, so that idea, therefore, that certain kinds of training will help you see the truth is the foundation of all cultural forms of learning, right? Whether it is in science, whether it is in the humanities, in music. I mean, in all of these, every single sort of human art or knowledge form has stories of people who just see the truth, right? Whether it's an Einstein seeing the laws of nature, or whether it is Buddha who is able to be awakened. I mean, to me, those are broadly speaking in the same category, and cognitive science doesn't deal with that. Now, whether that is computational or not, we don't even know what they are, let alone being computational. I mean, there is no current account of how is it that mathematicians learn what they learn, or scientists really have scientific insight. We don't have that.
Yeah, I would like to talk about some of the people in the society. Some will say that these type of persons are genius. They have really less knowledge, but their imagination is better than the knowledge. That Einstein said that imagination is better than knowledge. So what is the origin of this knowledge of such kind of people? Like if you can take any example, mathematician, physicist, medical scientist students, or even IIT students. So some students have they have very less knowledge, but they can do better than any other students or any other people. Why?
My own answer is it's some biscuit that they ate when they were kids.
Now you have to reveal the name of that biscuit. That's the
No, why I say that is we are all after that. It's the genius bullet or whatever it is. But let me rephrase that question. As a human being who lives with other human beings, we are all fascinated with people who have some special skills, right? Whether it is somebody who can jump 3 times their height, whatever it is, right? Some extraordinary ability fascinates us. And therefore there is a question of how do you, and it also fascinates us and it makes us envious. And humanity is primarily driven by one of these two. One is the positive end, which is curiosity, and the negative end, which is envy. So fine. I mean, there are any number of management books to be written about how do you become innovative or creative or these things. Okay, but from a scientist's perspective, especially when you are trying to understand human beings as like bacteria, extraordinary creatures, but with capacities that are explained at the biological level, we really don't necessarily want to ask the question why Einstein was Einstein. Because what's interesting, so a flip of that would be to say it's only because we take vision and walking and language and everything for granted that we think Einstein is so great. If Einstein did not have hands and ears and eyes, you would feel like, who are these amazing creatures who are able to, jump across buildings and, take a glass of water and drink it. Just imagine how difficult would that be, right? And so, what cognitive science tells us is really how hard the easy things are, and perhaps how not so important the hard things are. I mean, I would rather find out why you can just open your eyes and see the world, because that's as big a mystery now as relativity was 100 years ago.
If not mathematical genius, at least calculational prodigies have been explained pretty well. Both Shakuntala Devi's case have been well documented in terms of how she learned what she learned. The techniques that she uses. They are no different from the ordinary, is the conclusion in general. At least a couple of French or German prodigies being studied.
I see.
And the conclusion seems to be they are extraordinary in their commitment to what they are doing. And therefore, they bring an extraordinary focus to the learning process itself. And they deal with numbers very, very differently from you and I. They memorize a lot of facts. We think that they...
I feel like while that might be an explanation, that falls under my management theory of the universe explanation, right? Which is to say, how do you become innovative? So you should, number one, have focus. Number two, be passionate about your field. Number three, learn from others. I mean, come on, of course you have to do all those things, but it's not an account of how the world works. But that's my point is, on the other hand, if we were to find out that the world, so to take the Platonic dream, or a version of the Platonic dream, which says that, or the rationalist dream, which is that somehow the world is intrinsically transparent to cognition. Right? It may take effort, but at some point it's going to give you insights. If that's a very deep claim about the world, because it's saying that the world is not something random. It is actually by its very nature open to reasoning and capacity, which by the way drives all of science, though nobody has managed to make that into a computational theory. Right? If that was true, it would be a much more profound thing than why Einstein was able to do it. Well, the answer would be Einstein was able to do it because he landed on that thing that was anyway outside him to start with. But frankly, we have no way of knowing any of those. One last question. Go ahead.
What is your comment on Fodor's stance about we don't learn through language, it's not hypothesis testing and all those things, and everything can be reduced?
I mean, first of all, his arguments themselves are now more than, if you look at the original arguments, they're 30, 40 years old. Even the latest version of those arguments are now 10 years old. And we now have much better understanding of how learning happens. I don't mean in the natural world, but machine learning and other more computational techniques. So I haven't seen Fodor rebut this latest thing. So the Bayesian accounts of learning, where basically you don't have a strict separation between what is innate and what is learned, because essentially what you learned yesterday is what is innate today. But there is still the question of, there must be some initial thing out of which you bootstrap from. What is the minimal, so I think a far more productive research question would be, given a certain computational, let's just stay within the world of computation, forget how people and monkeys and others learn. Let us take a computational question. You might ask, is there an intrinsic lower bound given a question to the starting point from which you can get to that goal using a sequence of learning processes? So that is to say, just as cosmograph complexity and other things tell you what is the optimal code for a given set of information, it may turn out that there is an optimal learning code, right? So there might, which would be corresponding broadly to the entropy of the entity in the information theoretic sense. So if we can characterize that somehow in order to be able to learn some X, there has to be an X bar, which is the minimum amount you need to have to be able to learn X. That would be great. But I don't think we are anywhere close. I mean, it's possible, but I don't see too many people trying to attempt that. All right, thank you. So it's 3:30. We are back at 4 for the project session. So you have to see how